Again, I've focused on this lesson when I'm with you one-on-one in your building, so hopefully I'll be able to go through some of these examples a little bit more quicker. Remember that when we're multiplying scientific notation, everything is a multiplication problem here. So even from this multiplication to in-between multiplication, everything's being multiplied so that we can do a little rearranging and do this problem. Now we talked about writing each of these in standard notation, writing it out, multiplying it, and then bringing it back into scientific notation, but that becomes maybe a little cumbersome when you have a little bit larger exponents. And so we're focusing on a strategy where we group these guys together. So you can see on my whiteboard here that I've multiplied that out. And then also we have 5 10s here, and we have 9 more here for a total of 14. So there's something wrong though. 37.653 is greater than 10. So we're going to move that back and make it 3.7653. But then of course we have to do something with the exponent to take care of that. So we're going to make that to the 15th power. So that is 1a. Here's example 1b on the bottom of page 160. Again, we have two scientific notation problems being multiplied. And so I'm going to take 7.3 and multiply that by 2.93. And I get 22.0629. And then again with the exponents, -8 plus -3 is -11. The problem here is that 22.0629 is greater than 10. So we're going to make that decimal back one place, so 2.20629. But in this case, we're moving the decimal negative, so that's to the left. And we've already helped it out by moving it one place. And so now the exponent on the 10 will only be -10 instead of -11, because again, we've already moved it back 1 to make sure that it's greater than or equal to 1 and less than 10. For problem 2a on page 161, we have a division problem. So 4.62 times 10 to the 5th divided by 1.4 times 10 to the -9th. Of course, we could write those out in expanded form or standard form and do the division and then bring it back to scientific notation. But in division, we're going to just do the same thing that we did in multiplication and take care of these two guys first. So 4.62 divided by 1.4, which you can see on the side here. I got 3.3, which is nice because that's already greater than or equal to 1 and less than 10. And then when we're dividing, there's a couple of different things you can think about. For one, you can remember the rule, which is to subtract the exponents. So 5 take away a -9 becomes 5 plus 9, which makes 14. Another way to think about it is negative exponents move and become positive. So going back to lesson 4.2, negative exponents move. So a lot of examples in lesson 4.2 had negative exponents in the numerator and we moved them to the denominator. But in this case, since the negative exponent is in the denominator, it's going to move to the numerator and become positive. And again, if 10 to the 9th power joins 10 to the 5th power, then we're going to get 10 to the 14th power. So that's an example of dividing. And then the real trick, I think, is when it comes to adding and subtracting, because when you multiply powers with the same base, you add the exponents. And when you divide exponents with the same base, you subtract the exponents. But when you add and subtract, you can't add or subtract the exponents. You actually have to make sure that they have a common exponent and a common base in order for you to work with it. So I'm going to skip ahead to example 4 on page 162. Example 4 has addition and subtraction problems using this scientific notation. So we have 1.7 times 10 to the 5th power, 7th power, plus 6.25 times 10 to the 5th. Okay, so hopefully you're writing this down and you're making yourself some notes here. I've done a few of these problems with you in our one-on-one time, so hopefully this is just a refresher for you on adding scientific notation problems. So the same rules apply to subtracting as well. We have to have that common exponent or that common power with the same base and the exponent. So it really doesn't matter if you go to both of them being 10 to the 7th power or 10 to the 5th power. Let's just make 10 to the 7th power 10 to the 5th power. So if we were going to make 10 to the 5th power, what would we have to do to that 1.7 in order for it to be an equivalent expression here? So 1.7 times 10 to the 7th is 1700000. So it looks like that. That's how it currently looks. If we were going to shave off two of those exponents, that's 1, 2, 3, 4, 5. It would actually be 170 plus 10 to the 5th power. So now we have similar exponents here. We have 10 to the 5th and 10 to the 5th, but that does not become 10 to the 10th. Okay, it's just 10 to the 5th power. Okay, and then we can add 170 plus 6.2. So that's 176.2 times 10 to the 5th. But you're probably already noticing that 176.2 is greater than 10, obviously. So we're going to change that to 1.762 times 10 to the 7th. Now, you might be wondering, why didn't we just switch it to 10 to the 7th over here? And maybe we'll do that on the next one so that we don't have to do figuring out in the end. But either way, it will work. But on this next one, let's go ahead and go with the smaller exponent and see if that helps us with having to do reducing in the end. Okay, so the next example and the last example that we're going to do is 4b. Go ahead and write that down on page 162. 4b is 0.00864 plus 5.67 times 10 to the 4th. Okay, so in these problems, we first of all have to make sure they're both in scientific notation. Again, we could change this to expanded form or standard notation and then add it up and then change it back. But since this is focusing on computation and working with scientific notation, we're going to change that first one to 8.64 times 10 to the negative 3. Okay. All right, so, oops, sorry, this was 5.67 times 10 to the negative 4th. Okay, so on the last example, we went with the lesser exponent. So on this one, let's go with the greater exponent. So let's leave this as 8.64 times 10 to the negative 3, and let's change this to something with 10 to the negative 3. So the original problem is 10 to the negative 4th, so we move that back 1, 2, 3, 4. And so if we want to change it to 10 to the negative 3, it's going to be 0.567 times 10 to the negative 3. Now we can deal with these two guys right here. So I'm going to take 8.64 plus 0.567 and get 9.207 times 10 to the negative 3, and then we don't have to worry about changing that to proper standard notation because it's already greater than or equal to 1 and less than 10. Hopefully this helps you with lesson 4.5. It's a little tricky trying to keep track of all the different things that you can do with scientific notation, but I'm positive after you do the homework problems and take your self-check quiz that you'll be on your way to learning how to compute with scientific notation. Thanks.